Hi everyone, in today's video we are going to discuss the layout plan and different elements of a wind power plant and their functions. Objectives. At the end of this video, you will be able to number 1. Visit and identify the various components used in wind power generation plants. Number 2. Prepare and draw the schematic diagram of a wind power plant. Let us discuss on wind power plant. A wind power plant, also known as a wind farm, is a facility that harnesses the energy from the wind to generate electricity. Here are the basics of how a wind power plant works. Wind turbines. The wind power plant consists of multiple wind turbines, which are tall structures with large blades. These turbines are strategically placed in locations where there is a consistent and strong wind flow. Wind capture. When the wind blows, it causes the turbine blades to rotate. The shape and design of the blades help capture the kinetic energy of the wind. Mechanical energy. As the blades spin, they turn a shaft connected to a generator inside the turbine. The mechanical energy from the rotation is converted into electrical energy through the generator. Step 1. Visit the windmill power plant and note the details of the plant. Number 1. Capacity of the plant 4.2 megawatts. Number 2. Output voltage 33 kilovolt. Number 3. Maximum load current 200 amperes. Step 2. Trace and identify the equipments or parts used in this windmill power plant. Number of blades 3. Most turbines have 3 blades. When wind flows across the blade, the air pressure on one side of the blade decreases. The difference in air pressure across the two sides of the blade creates both lift and drag. Gearbox. In a wind turbine, the gearbox is an essential component that helps convert the rotational speed of the turbine blades into a speed suitable for generating electricity. The low-speed shaft is connected to a gearbox, which is a set of gears with different sizes. The gears in the gearbox are arranged in such a way that they can change the speed and torque of the rotation. Generator. It's important to note that wind power plants may use different types of generators depending on their capacity and design. Commonly used generators in wind power plants include asynchronous or synchronous generators, with the latter being more prevalent in modern wind turbine technology. The main shaft of the wind turbine is connected to a generator. Exciter. The exciter current is controlled by a turbine controller which senses the wind speed. Based on that, it calculates the power what we can achieve at a particular wind speed. Turbine controller. The wind turbine generator produces alternating current AC electricity as the rotor rotates within the stator windings. The AC output from the generator may have varying voltage and frequency depending on wind conditions and turbine speed. The conditioned DC power is fed into an inverter or other power conversion equipment which converts the DC power back to AC power with the desired voltage, frequency and phase characteristics. The AC power is then synchronized with the grid and transmitted for distribution to consumers. Line Converter Unit, the LCU, also includes a grid-side converter, GSC, connected to the stator windings. The GSC converts the AC power from the stator windings to DC power and then inverts it back to AC power with the appropriate voltage, frequency and phase required by the grid. High voltage transformer. The primary winding of the transformer is designed to receive the low voltage, AC power, and through electromagnetic induction, it converts or step up the voltage to a higher level. Internet Supply Unit, ISU, and Chopper. The output voltage of electrical generator is given to a rectifier and rectifier output is given to line converter unit to stabilize the output AC that is fed to the grid by a high voltage transformer. An extra unit is based to give the power to internal auxiliaries of wind turbine like motor, battery, etc. This is called internal supply unit. ISU can take the power from the grid as well as from wind. Chopper is used to dissipate extra energy from the rectifier unit RU for safety purpose. Wind turbine. Wind turbines will generally operate between 7 miles per hour, 11 km per hour and 56 miles per hour, 90 km per hour. The efficiency is usually maximized at about 18 miles per hour, 29 km per hour, and they will reach their maximum output at 27 miles per hour, 43 km per hour. A wind turbine turns wind energy into electricity using the aerodynamic force from the rotor blades, which work like an aeroplane wing or helicopter rotor blade. Grid. To connect to the national grid, the electrical energy is then passed through a transformer on the site that increases the voltage to that used by the national electricity system. Tower. Made from tubular steel, the tower supports the structure of the turbine. Because wind speed increases with height, taller towers enable turbines to capture more energy and generate more electricity. The turbines comprise an 80-meter tall tower and 355-meter long blades. Nacelle. The nacelle sits atop the tower and contains the gearbox, low and high speed shafts, generator and brake. Some nacelles are larger than a house, and for a 1.5 megawatts gear turbine can weigh more than 4.5 tons. Hub. Part of the turbine's drivetrain, turbine blades fit into the hub that is connected to the turbine's main shaft. Low speed shaft. Part of the turbine's drivetrain, the low speed shaft is connected to the rotor and spins between 8 to 20 rotations per minute. Brake system. A turbine brake keeps the rotor from turning after it's been shut down. Once the turbine blades are stopped by the controller, the brake keeps the blades from moving, which is necessary for maintenance. Step 3. Note down the daily average power output of the plant. Step 4. Note down the minimum RPM of turbine to maintain the rated voltage. Step 5. Note down the chopper, circuit characteristics and its importance in the turbine controller. Step 6. Note down the protection provided from natural calamities. So far, we have discussed identifying the various components used in wind power generation plants and preparing and drawing the schematic diagram of a wind power plant.